So, as a review of everything we've talked about, what's the whole purpose of having a network?
Communication. Service the clients.
Share resources.
Okay, share resources.
Share resources. So a share resource is the purpose of having a network. In order to have a network, we need to have what components? What physical components need to exist on our network? So let's say our resources is two computers, 3 computers. What do we need in order to connect these computers to a network? A router.
Some cable.
Okay. A router is going to get us out to other networks, right?
Right.
We'll do this the old www internet. What else? We need a switch. We need some sort of concentrated hub or switch that is going to allow these devices to communicate to each other. Okay. So that switch is going to send the Ethernet signal, so an Ethernet switch, from what on the host? What do I need there? A what? No. A NIC.
Oh,
A NIC.
something right.
Network interface controller card. The network interface controller card, this one is obviously Ethernet, wired Ethernet. What's another type of NIC?
Wireless.
Wireless. Okay. And they both use the 802.11.
No,
802.
Yep.
IEEE standards, CSMA-CD and CSMA-CA. 802.11 is wireless. 802.3 is Ethernet. Okay, so we have 802.11 and 802.3. This is Ether, and this is wireless. Okay, some basic standards we've already talked about here. So here we're using 802.3 Ethernet communications. Uses carrier sense for multiple access with collision detection, CSMA-CD. And now that we are on a network connected, that we can actually exchange data with each other. How do we exchange data with other networks? Now we're moving up the OSI layer with a router. A router is a layer 3 device that helps us create networks. If we have networks, we're going to have logical addressing, right? Logical addressing, so we can group computers together logically. So these physically are grouped right here as we can physically see them. What differentiates this computer from this computer on this physical local area network that we created? I'll try a different color. A MAC, that's right. The physical address is the MAC address. So a MAC address consists of 2 parts. What are those 2 parts?
Letters and numbers?
No, not letters and numbers, but 2 parts. It's split up into 2 parts. There's 12 total hexadecimal characters, which are letters and numbers, 0 through 9, A through F. But what?
Isn't it a manufacturer and then the
Yes.
individual?
This is the organizational unique identifier, or the manufacturer. So A01E76. And then this is the actual unit ID. 0012A4. So that's a MAC address. All 12 hexadecimal characters, 48 bits in size, is a MAC address. And each network interface card has its own unique MAC address that's burned down at the factory. So if there was a wireless adapter in this computer as well as a wired, there would be 2 MAC addresses that this computer would have. Make sense? Okay, very good. So this is the physical aspect of our LAN. The logical aspect, we need a logical address, which is IP addressing. IP version 4 to be exact. IP version 4 is split up into 4 what? classes. And 4 octets. Good, that's right. So we have 1, 2, 3, 4 octets. 32 bits. 8 bits in each octet. 8 times 4 is 32. You can do math. And we have classes A, B, C, and D. Why do we separate them into different classes? It identifies which part of the address is the network part and which part is the host part. Because any good logical addressing scheme identifies the network portion and the host portion. Which computer is inside of this network that we created here? Question?
This goes back to my original argument that I was having. The classes are really preset masks then, based on what you're
Yes,
saying.
that's exactly what we're doing here is identifying the classes helps us identify the actual network mask, which masks off our network portion, which then leaves the host portion for the host to determine. So that's it. And it's just a preset rule, and that's where we talk about classless routing, and that's where we get into subnetting, is because we take away the whole concept of having individual classes and we just say it's classless because we're going to determine based on wherever we want the bits to flow for the subnet mask.
Is that because I thought there was a class E also?
Nope.
Technically.
Well,
Or is that
class
what-
A, B, C, and D are the 3 that you're going to use are A, B, C, and D,
Okay.
or C, and manipulate.
And none of this applies to IPv6.
Right, none of this
Say that
applies to
enough.
IPv6. This is IP version 4. Yep. So with the classes, at class A, the first octet is going to identify the network portion, and we do that by turning all the bits on. So in an octet, we have 1, 2, 3, 4, 5, 6, 7, 8 bits. Each bit has a value. The first position has a value of
0, 1,
1. So the decimal value of the first bit is 1. Next one has a value of
2,
2,
4,
4, 8,
16,
16, 32,
128.
128. Yep. So when I turn all of these on, if I turn all of these on, except the last one, I add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, and that will equal 254. If I turn this last bit on, then we have to add one more to this, and that gives us 255. So all the bits turned on add up to 255. So based on what bits are on, it's going to give us the decimal version, which is what the humans, you and I, use to write down. So for class A, the first octet identifies the network side, and the last 3 octets are all off, are all zeros. Class B, what is it?
255.
Version 2. For class C,
255, 255, 255. 0.
and for class D, we don't worry about for class D, it's an actual multicast address. Class D is multicast. Imaging systems, streaming audio and video services use multicast. Okay? So now we know the different classes, and we can determine the different classes by looking at the first octet and knowing what decimal number is in the first octet. For a class A, if the first octet is between numbers 1 and 126, it is going to be a class A. If it's between 128 through 191, it's a class B. Class C, 223, 192 to 223, and then 223 to 255 is a class D. Okay? So this just helps us identify the class, identify the default mask. So if this LAN is going to be the 172.16 network, how many networks do I have?
3 or 2.
One network, the 172.16 network. What if I wanted to create another network? Well, what is the next number I could use for the network? 172.17. So you just keep incrementing this. This happens to be in a private IP range, right? 172.16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, all the way up to 32. Yep, actually 31, not 32, 31. So this stops at 31. Okay. So this is a private range for Class B networks, because if you look at the first octet, it falls into Class B. What is the private range for Class A?
10.
10. Only one network you're given for a Class A private. And for Class C?
92.
Yep, 192.168. And then the third octet is anything from 0 to 255. So there they give you 256 networks that you can assign and play with on your own LAN that you create. So we're going to use the 172.16.00, and we're going to use the default subnet mask. How would I note that with CIDR notation? Classless interdomain routing notation. This is how many total bits are being used in the network mask.
16.
16, the first two octets, 8 here and 8 here, that gives me 16 total bits. That's how I designate this logical network that I just created. I have how many hosts on this logical network? Where are my 4? My obvious 3 PCs, 1, 2, 3, and my router. Each interface on a router essentially creates a logical network. So I have 4 devices, 4 hosts on my network. This first, this is my default gateway. This is the device that's going to route me out to the internet if I need to go out to the internet, right? Or route me out to any other network that may exist. So it's my default gateway. This is my default device I go to if I don't know where to go. I'm going to assign it my very first IP address. What is the very first IP address, Carla?
172.16.0.1.
172.16.0.1 is the very first usable address. And that's the IP address I'm going to assign to my router. What is another random, go crazy, somebody, random IP address I can assign to this workstation?
124.16.123.5.
I like that one. That's very random. 172.16.123.5. That is a usable IP address in this range. This range starts out 172.16.0.0. This identifies my what?
Network ID.
My network ID. 172.16.0.1, as Carl identified, is my first usable address, and that can go all the way to 172.16.255.254. Those are all my usable, and then the very last, which is my broadcast ID. A broadcast ID address. So I can use any number I want to in here. So let's assign .5 over here and .6 here. We'll just, that's the last octet. Okay, to save on me writing.
.6 and 7, since you've got 5 twice.
Yeah, 172.16.
No, this would be 0.
There you go.
16.
Oh,
There you go.
I'll write it all out. That's okay. My bad. So if this is the IP address, let me write it over here.
Are you recording this?
Yes, I am recording this. 172.16.0.6. That's my IP. What's my subnet mask? /16 means
65.255.00.
255.255.0.0. And what is my gateway address?
255.
No, my gateway address.
172.16.0.
There it is. 172.16.0.1. Very good. So that is the device that this computer is going to go to. If it's not talking to a local device, it's going to go to the default gateway if it wants to go to Google or some other website that may be out on the internet. Make sense? That's my default gateway. One more thing I need to have on here in order to resolve names is a DNS server. The DNS server is going to resolve a human readable name like www.yahoo.com into an IP address. And a very good, useful public DNS server is 8.8.8.8, which is Google's open DNS server that they allow anyone to use to resolve names to IP addresses.
Right. That thing must
Okay.
be huge.
It's awesome. And I'm sure there's many of them.
Yeah.
Okay, so
Huge network.
now that we have a basic concept of what a local area network is, what has to exist in order for this to work, now let's take a look at controlling these resources and managing these resources. And there's two ways that we can do this. We can do it through a distributed or a peer-to-peer environment or a centralized environment. A peer-to-peer environment, where and who manages who has access to what.
The host has access to host directly.
Yeah, so if I have a folder on this computer, I have to be on this computer to identify to allow or disallow these other two computers to access it, right? And if this computer has a file here, I have to be on this computer and identify to allow or disallow the other two computers. This is a peer-to-peer or distributed management. It's a major pain in the butt, especially if you get up to anywhere from 10 or more computers on a network. Because if Sally is using this computer and Sally leaves for the day and turns off her computer, guess what? Can these other two people access that file or folder? No, they cannot. So it's important to, if you have a large network, to centrally manage it with a server. That's where we get the server client infrastructure. So we put in, over here, we're going to plug in a server. And this is where we're going to have all of the folders and subfolders that everyone has access to. Make sense? And we centrally manage the resources here. And the server always stays on. And the clients are not sharing files with each other on their own computers. They're storing them on the server. And that's where we manage who has access to what folders and what resources. And we do that with something called Microsoft Active Directory, right? Some sort of directory service that is essentially a database with all of these records that have relationships with each other that identify, do you have access to this resource or not? Yes or no? And if you do, what are those resources? Okay, so I'm going to erase this. And we start talking about Active Directory.
Ready for that?
No. I read it, but do you think I understand it?
I'm just wondering if I'm ready for reading from Jason.
Oh, he recorded it. I know, I already did. I was like, "Ooh."
Okay. Okay, Active Directory is Microsoft's directory service that helps manage resources. And we manage resources using a database. The database X.500 is the largest, most organized database of resources that can exist. It identifies every single attribute of all of these resources.
What was that called?
A X.500. Yep, you might stumble upon it a little bit. A scaled down version of it is called LDAP, Lightweight Directory Access Protocol. It's a protocol and a standard that identifies a record name and all the attributes of that record, and it's lightweight.
On YouTube when it was
Yep, you'll see some LDAP references. And the idea here is that if I create a directory of users here, and I say the first name field of this record is going to be F name for first name, and the last name is going to be L name, then how do I tie those fields for when this Active Directory database has a first name field and it's called first name and a last name field called last name? How are those referenced together? How do we tie to make them the same? We don't. It makes it very difficult. So in order for these two directories to talk to each other, we establish a standard called the X500, or a lighter version of it called LDAP, that allows this database to use first name as a name for the first name record and last name for the last name, and this one will follow the same suit. It will also use first name for the first name record and last name for the last name record. Does this make sense? Remember our database training? Create an access database, we create a record, and records all have fields, and the field for first name, we're going to call it what? What are we going to call that field? Whatever you want. But we try to follow a standard, especially when we're talking about directory services that communicate together. So I have a wireless access point that wants to try to authenticate a user that wants to connect to it. The wireless access point goes, what is your username and password? It's going to collect the username as a username is the name of the record that it's going to collect from you. And then it has to send that to Active Directory and ask Active Directory, does this username match your records as being allowed to access your wireless network? Well, if this access point doesn't speak the same language as Active Directory, Active Directory is going to go, what did you just ask me for? I don't have a username field. I have no idea what that means. And that's where we have the naming structure that you may have come across when you read the chapter of common name, right? Domain name, right? All of those naming, okay? So that's why it's important to have that naming scheme exactly the way that LDAP is supposed to be referenced. So these different devices and directories can communicate from one directory to another and query the right information out of it. Okay? Because Microsoft could have stored this any way they wanted to. They could have stored all of these records any way they want. But they decided to follow the standard, industry standard, so we can interconnect a Cisco wireless access point into Active Directory or an Apple wireless access point and have it use a list of usernames and passwords out of Active Directory. Okay? So, this database is stored on something called a domain controller. It's an actual server that we install the role Active Directory domain services, which we've done already. So the server has to be running a Microsoft operating system, Windows Server 2003, Windows Server NT, Windows Server 2000, Windows Server 2008, 2008 R2. All of those are capable of running Active Directory. That server needs to have a static IP address. Why does it need a static IP address?
you don't want the address bouncing around.
You don't want to bounce it around or changing, because then clients or devices that are trying to request access to it aren't going to be able to find it because the IP is going to be changing all the time. So we need a static IP address. And then we need to identify the site. And this is where sites and services comes into play. You might have stumbled upon that. What a site is, it's essentially a network where this domain controller is going to exist, or a subnet where it's going to exist. It just gives the domain controller an idea of where it fits into the whole network realm. Because we can have domain controllers in other networks. Let's say that we have sites. We have a corporate site here in Fenimore, and we have another remote site in Prairie du Chien and Lancaster. They will be in different networks. This is going to be the 172.16 network. That will be the 172.17 network. So if I have Fenimore here, and then I have Prairie du Chien here, and Lancaster here, the Fenimore is going to be the 172.16 network. Lancaster's 172.17 network. And the Prairie du Chien is the 172.18 network. So a site for the Fenimore site is going to be identified as the 172.16.00 site. And the Lancaster site will be referenced as the 172.17 network. And this all makes sense when we start poking around and taking a look at these sites. So if the domain controller is going to sit here, it knows it's in the Lancaster. And if we have another domain controller as a backup domain controller located here in Fenimore, we're going to have two domain controllers. And if we make a change to a record on the Lancaster domain controller, that information has to be synchronized to the Fenimore domain controller. Because what happens if this user drives away from Lancaster, drives into Fenimore, sits down on a computer here in Fenimore? They're going to try to log in, but we change the record here. They're going to expect it to exist here as well, because this is all one big company, right? Kind of makes sense. We're kind of seeing it here. So the physical aspect of Active Directory is the actual server. And the server that is running Active Directory is called a domain controller. So we can run domain controllers. We can have as many as we want. It's best to have more than one, because if that one domain controller goes down, who can access the resources on that network? Nobody can, because there's no authority that says you have access to this resource or not. Okay? And then we have the logical aspects of Active Directory are the forest, domain, OUs, users, and computers. These are logical records, or these are records that logically represent physical components. So a forest is a collection of domains. It establishes trust between the domains, that they can share resources between domains. A domain is a collection of OUs, users, and computers. A domain is typically tied to an organization. Let's say it's Hidden Valley Ranch. They would have their own domain. Do you know who owns Hidden Valley Ranch? Clorox.
No, really?
That's company.
What's wrong?
Clorox, which we associate what with? Clorox bleach, right? Clorox owns Hidden Valley Ranch. So Clorox would have the forest that would exist, and inside there they would have the bleach domain and the Hidden Valley Ranch domain. Does that kind of make sense? So you have the overall parent organization, which is a forest, which is a collection of multiple domains. And then in there, those domains, you would have the Clorox bleach domain, the Hidden Valley Ranch domain, and whatever else they've got their fingers in. Does that make sense?
So it'd be like if you like in a workplace, if they had a domain for like accountants and like a domain for
No,
like a different department.
domains are much larger than that. Think of the entire organization as
Like
the
Mars,
domain.
Mars bars or something like that. Mars is a brand, they own
Yeah.
some of the-
Mars, they own.
Stuff like
Yeah,
Huh?
Snickers.
I worked at Kimberly Clark,
Uh-huh.
a multi-international corporation. They had 2 domains. One was every computer, every workstation, every resource they had around the world. The second domain was their websites for their vendors and stuff like that, so that you can go on a website, order something, and it'll automatically get pulled from stock and all the rest. But 50,000 some odd stations were all covered by one domain. The only reason they had the second domain was the separation of the vendors.
For probably security,
Correct.
to kind
Oh,
of
yeah, very
separate
much
the
so.
security. Yeah,
Like,
definitely.
Big part
So what I was
was
talking
connecting
about
the
was
two.
user groups, right?
So let's do this concept. Let's just bring it down a little bit smaller. Let's say that the Wisconsin Technical College System is one organization, right?
Yeah.
That includes all the technical colleges in the state of Wisconsin. Fox Valley, MATC Madison, MATC Milwaukee, Southwest Tech. Okay? There's many more, I'm not going to list them all. That includes all of these individual colleges. So we have the forest is WTCS, Wisconsin Technical College System. Inside we have domains SWTC, domains MATC, domains Fox Valley Technical College. Does that make sense? And inside of that domain of Southwest Tech, we have organizational units. We have faculty, I can't spell. We have faculty, we have students, we have admins. So these are all OUs, organizational units.
So you would consider that like each individual department? also?
Yeah, each department would have its own OU, or each categorization. So administration is an OU, but inside of administration, we have accounting, we have student services, we have financial aid, and so forth. Does this kind of make sense?
So are those more OUs or are they separate?
No, good question. Those can be more OUs, or they can be groups. Yep, user groups.
So.
And then the user, Sally, is put into the financial aid group.
That users folder that we have on our servers, we can add groups inside of that folder or add. Other
No, you're talking about folders now. That's a
Or OU,
that's
that's
OU, the OU,
Yeah.
yes.
And so inside
That's
that
an organizational unit just to organize, and we're going to get into more detail on how and why we want to organize or group. That's a bad word to use. Collect these resources into an area so we can apply certain types of security, certain types of group policies on how this resource is going to act within our environment. But so let's say that I now leave Southwest Tech and drive to MATC, and I want to log into their computers there. If this is how it was set up, I would be able to log in with my faculty login that I was given on an MATC computer and still be able to hit file print and print to my printer here at Southwest Tech. Still be able to access the files stored on the file server over in our server room.
It's not set up.
Does that make sense?
It's not set up.
No, this is not how it's organized. No, this is just a grandiose idea. Okay? To give you guys a
And all your
visual.
permissions and everything we maintain.
Yeah, and there's a lot of permissions and other things we haven't even touched on yet. This is just the logical concept and structure of a Active Directory domain. Okay, so these domains function independently, but there are trust relationships because they are still in the same forest. And the physical aspect of this domain, how it exists, there has to be a domain controller server who is in charge of all of these OUs, users, and groups
And that
and
doesn't
computers.
store the information itself, it just routes you to
No,
the
no.
server, right?
The domain controller stores all of this in a database.
Okay.
Yep. Okay. So now let's take a look a little closer at a domain. What is inside of a domain? So this is a domain, we'll call this domain SWTC. Just we'll go with that concept. The domain SWTC has physically a domain controller that resides in it. It has workstations, computers that can access resources or be used as a means to access resources in our domain. It has printers. It has users, Bob and Sally, and we organize Bob and Sally and our three-headed monster here into groups. Okay, is this making sense?
Yeah.
And we organize, just like we do in our normal everyday lives, we organize multiple things of the same thing into a group, right? So we can better maintain it. So the user Bob exists in this domain, and we're going to organize Bob by putting Bob into the OU faculty. Sally is going to be in the OU staff. But they both are going to be in the special projects group
Okay.
for doing special projects, whatever that may be. Okay, does this make sense how we can organize it?
Yeah.
Now, Sally can also be in another group called financial aid. So a user can be a member of multiple groups based on their function. Why is that important? Because financial aid can have a financial aid printer, and we're going to have this printer is going to be used to give resources to print only the financial aid group people.
And not just that, I mean, access to other files and folders and other...
Yeah, it could be other files, folders, other servers. And the reason being is because the financial aid printer has blank checks in it. And we only want people in financial aid, who is Sally, to be able to print to this printer. Make sense? Why? That's one reason. Question?
What determines that faculty and staff is considered an organizational unit rather than a group?
What determines that faculty and staff is an OU as opposed to them just being groups? You. You determine it. You are the one that's going to organize your organization. Or, more than likely, you're going to get a job where it's already been organized for you, and you just have to maintain what they currently have and learn how they organized it. A lot of times, they don't even know that OUs exist.
Yeah, so they may set that up.
So they may
as a
be
group.
just multiple groups, and it can get crazy, right? So why don't we take a break? We'll come back, and we'll take a look at what this looks like.
Numb, my brain's numb again. It's numb again? Yep, I kind of.